In the previous video, we have implemented a lot of variables that will be used by our map brain. And actually, transform.parent we are using in a map visualizer, so we do not need it here. Okay, with this deleted, let's implement our methods for our map brain. First, let's start from start. And here we are going to calculate the mutation rate %, which will be equal to mutation rate divided by 100d to create a double value, and crossover rate % equals crossover rate divided by 100d. So this will give us the % value for mutation rate and crossover rate. So let's create a public void run algorithm method. Okay, let's go to our map generator class. Okay, let's slide down. We are calling map clear map grid equals new grid map helper map equals candidate. So for sure we need those three methods. So let's copy this. Let's go back to our map brain and let's paste those in run algorithm. So we need to run those, and we have not width but width of map and length of map. Okay, and randomly choose start and exit position. What we have here is, instead of random placement, we have random start and end. Start edge, we have our start position edge and exit position edge. So minor changes in the names. Okay, and do we have this one, exit position edge? Great. What we need to add here is algorithm running. Let's set it to be true, and start date equals datetime.now to get the current time, and we are going to call find optimal solution. We do not have this method yet, and we are going to pass our grid. Let's create this method, generate this method here. Great. But we also need a method called reset algorithm variables. So as you might recall, in the map generator we have cleared our map as well. Okay, I need to change the name a bit. And we need to do exactly the same here. We need to reset the parameters that we have preset to generate a new map. So total fitness this generation, let's set back to 0. Best fitness score all times equals 0. Best map equals null. Best generation map generation number equals 0. And generation number equals 0. And that's basically it. That's how we reset our parameters of our algorithm, which are those. And we are going to create a current generation in a find optimal solution method. We have resetted those two, this one, and best generation number and generation number as well, I think. Yes. So those are all parameters reset. Now we are able to implement this find optimal solution method. And here we are going to set current generation equals new list of candidate maps of population size. Great. Next we are going to loop for I equals 0, I less than population size. And we are going to say var candidate map equals new candidate map, and we are going to pass our grid, and we are pass our number of night pieces. And that's the way we are creating a candidate map. Next we are going to say candidate map create map, I think it was, and we are going to pass our start position our exit position, and of course true, always true for our auto repair, to always generate a valid candidate map. And next, we are going to say our current generation, add our candidate map. Okay, so what is the plan now? Well, as I said previously, this algorithm can run for quite some time, usually about 4 seconds. So, to not block our main thread, we are going to use coroutines to split the generation between multiple frames, so we can see some progress. Later we are going to implement some UI to show us the progress of our generation. But for now, let's call start coroutine. And let's create genetic algorithm coroutine. Okay, we do not have this method yet, so let's Alt-Enter, generate it, and this will be IEnumerator. Great. So let's start implementing this coroutine in this video, and we will finish off in the next couple of videos. So what we want to do here is first set total fitness this generation to be 0. Next, we need to create an int best fitness score this generation equals 0. So this will store the best fitness score for this generation, and we are going to use it to set our global best fitness score and the best map. Next, we need to create candidate map best solution this generation, or best map this generation equals null. And now we need to loop for each our candidate in our current generation. What we need to do now is to call candidate.find, and I think this is the private variable, so let's go to candidate map, and we are going to change the find path to be public rather than private. Okay, let's go back using this arrow. We can call find path because the current generation will be recreated. At the end of this coroutine, we are going to call the crossover and mutation function to mutate our candidates, to create new candidates that will be a mix of the best performing parents from the next previous generation. Hopefully they will be a better match for our resulting map. So we need to first find the path if it exists. Then we are going to say candidate.repair. So if there wasn't any path, then we are going to repair this candidate map, and we are going to call var fitness equals calculate fitness, and pass to it our candidate map.return map data. And we do not have this method, so Alt-Enter and generate this method. Great. So now we are going to check if our total fitness this generation, first of all, we need to add this. We need to add our fitness score, and this will be used for our roulette wheel selection method that will choose our parents for our crossover. Okay, and for now, fitness calculation returns object. Instead, we want to return integer value. Okay, great, and now it all works. And we are going to check if our fitness is greater than best fitness this generation. Best fitness score this generation. If it is so, we are going to set best fitness score this generation equals fitness, and we are going to say best map this generation equals candidate. Okay, and below our for each statement, we are going to say if our best fitness score this generation is greater than best fitness score of all times, then we are going to set the best fitness score of all times equals this best fitness score this generation, meaning that we have found a better solution for our procedurally generated map. and we're going to say best map equals a best solution this generation, or best map this generation, and we are going to say deep clone. So we want to save this candidate because now we are going to modify it. And next we are going to say best generation number equals generation number. Great, so we have our data now. What we need to do now is to add to generation number, and we are going to say yield return wait for end of frame. I need also new wait new end of frame, and here we are going to say debug.log, and we are going to log the best of generation plus generation number plus, and we are going to print the score, so best fitness score this generation. So this will be the current generation generation number, and we are going to also add the score. Maybe let's type score here. Okay, great. Now what we need to do is we are going to say if our generation number is less than generation limit, so if we are still considering the next generation, we need to create it. So basically we are going to say list of candidate maps next generation equals new list candidate maps. So we want to create a new generation that will consist of new candidate maps that are a mix of values of obstacles from the best performing candidate maps from the current generation. But to do that, we need to perform two actions. First is crossover, so create those new children, and then we will add a mutation to add some variety to our generation, hopefully to find the global optimum rather than local optimum for our solutions. Of course, for our example, we can live with local solution. Anything that is better than few squares of road, we want to have a longer road, and that is our main aim. So to do this, we need to create a new generation. So while our next generation dot count is less than population size, and what was the name of this variable up here? So let's copy this and paste it here. Okay, great. So now, while that is true, we are going to call var parent1 equals, we're going to get current generation, and we are going to set an index using a roulette wheel selection method. So let's type roulette wheel selection, and Alt Enter to create this method since we do not have it yet. We will return an int, and we will discuss how to implement it in the next video. And we are going to copy this and choose the second parent. So basically we are going to choose two parents from our current generation, and preferably those with the best fitness score. But to preserve the variety, we are going to randomize the selection to give a chance of a map that has a slightly lower score to still take part in the next generation sometimes. Okay, so having those two parents, we need to create a candidate map, child1 and child2. So basically we are going to create new candidate maps by mixing the parents, so the candidate maps from the last generation, hopefully to achieve a better map. And we are going to create a method called crossover parents, which will basically put part of obstacles from obstacles array from one parent into one child and from the other parent into the same child, and do the opposite placement in the second child. We will also discuss it in the next video. So for now we are going to type parent1, parent2, and we want to get our children from this method, so we are going to type out child1 and out child2. So we are going to return the values created inside this method as the parameters for our candidate map child1 and child2 variables. And what we are going to do is child1 add mutation, and depending on our mutation rate, %, we are going to add some mutation to our children, and child2 also add mutation rate, and we want %. And after all of this, we are going to simply add to next generation the child1 and child2. And this is basically why we are calling at the start find path and repair it, because now we are going to assign as our current generation equals next generation, and we are going to say that if indeed our generation number is less than generation limit, we want to again start coroutine of type genetic algorithm, and if this is not the case, so else, we are going to show results. Okay, Alt Enter because we do not have this method, and we are going to implement it in the future video. Okay, it was a lot of code, and in the next video we are going to talk about the roulette wheel selection method. And by the way, if the IEnumerator doesn't work for you, you need to Alt Enter and import using, I think, collections.generic, because I have implemented it earlier. Okay, let's save it. And as I said before, next there will be a video about roulette wheel selection.